Welcome everybody. Tonight we have Ryan Lane talking about the Wikimedia architecture. If you don't know who they are, you're probably in the wrong room, watching and the wrong industry altogether. But anyway, so that's looking like it'll be a really good talk. Before we get started, we have a few announcements. Tomorrow night, the MySQL meetup group is going to be doing advanced MySQL replication for the masses. It's going to be here again, same time, same bat channel. Kind of the same old. If you are looking to go to the MySQL conference, don't forget it's next week. So if you want to register, be sure to use the user group discount. It's on our mailing list. If you want to go to Velocity, we also have a user group discount for that. I can't remember if I sent it out or not, but if not, it'll be out tomorrow. That's also 15 or 20% off, like usual. Early registration for that ends on the 8th, which I think is Friday. So that's in June, I think second or third week. The end of the month, we have two events, kind of foobarred the scheduling. So on the 26th, we're going to have a big mobile event about Android, iOS, and Windows phones. That's going to be another one of those big cross-group ones, so there'll be a good couple hundred people for that, really good speakers. And then on the 27th, we are having Silverstripe CMS, and I can't remember the name of their framework with it, but they're going to be in town, so they'll be talking that night as well. So they're on the event pages, so if you're interested, check those out. Our event tonight is hosted by GameSpot.com and CBS Interactive. We're hiring, so if you are into technology, cbsinteractive.com/jobs. We have basically any web tech, front end, back end, up and down the chain. It's not just PHP, so if you are interested, check it out. O'Reilly's sponsoring our books as usual. We have Programming PHP, Programming Collective and Intelligence, and then still some leftover Host Your Website in the Cloud from when Jeff Barr came out. Those boxes and boxes of books that he shipped us. I think that's all of my announcements. Oh, turn off your cell phones. Somebody always forgets. Don't let it be you. And then really quick, if anybody has 30-second announcements, you're looking to hire or you're looking to be hired or other community events, feel free to raise your hands and we'll go through that real quick. Go ahead, Curtis.
Curtis, with the social gaming startup, we're looking for people after it.
I'm Jonas from Huddler. We're a SaaS platform for online forum communities. We're looking for PHP developers, operations engineers, web developers. Huddler.com.
Tish?
Well, last time I was looking for PHP people. This time I'm looking for UI and Java people. So, any Java bodies listening that being here or UI people, let me know.
I'm Tony from Chegg, and we're just looking for the best engineers anytime. Definitely CBS.
All right. Dave, you had something?
I wanted to invite anyone who is curious to the next Node.js meetup. We're doing games on the 28th from the IGN headquarters, which I've never been to either, but it should be kind of interesting.
I'm Steven, and I work for Tripit. We do itinerary management. We're looking for front-end, back-end engineers.
Cool. All right.
I'm Suyash. With developer, I do mobile web stuff, HTML5, CSS3, WebGL kind of stuff. Made a cool game. So I'm looking for work, but part-time contract kind of gig. Not a full-time job. I have a day job, but part-time gig, part-time project, remote work is cool.
Jason?
So Wikia is hiring in PHP development and in operations, replacing me. If you're interested in working on a very large MediaWiki site, about the second largest in the world behind Wikimedia, we're hiring. SQL startup I'm going to is looking for front-end developers. So JavaScript, HTML, we'll be announcing here in the next
Cool. What?
I'm Carlos. I'm with Bundle.com. We are looking for front-end engineers.
All right. We covered a lot of good stuff tonight. All right. Ryan, you ready? All right. Turn on your mics. Two of them, unfortunately, but takes a second to warm up.
Hello? Yep.
Yep, there we go. And we're good to go. All right.
So I'm a fairly recent hire at Wikimedia Foundation. I've been working for them for about 6-7 months now as a full-time employee, and maybe a contractor before that, for about a year. But I've been volunteering with them for the past 6 years or so. And at my last organization, I used the information from the Wikimedia Foundation to architect the site that I was doing there as well. Because the documentation that's put out by Wikimedia Foundation and the ops engineers and the developers is really good, and it's really useful to building a very large-scale website that's mostly read optimized. These are the topics I'm going to cover, and I have to apologize because I kind of crammed 3 talks into one, and they're all really long talks. So I may not actually get through all of this, and even if I do, it might be rushed, and or I might go over time. So a little upfront information. These are the top 5 web presences in the world. We're number 5. In comparison for users, if you notice, we're very similar in the number of users that we have on our sites, but for every other comparison, we're dramatically smaller. Our revenue is much, much smaller. The number of employees we have is much smaller, and the number of servers that we have is dramatically smaller. And the number of employees that we have mentioned here is not operations engineers. This is all of our employees. Of course, these numbers are mostly a guess in some ways because not all of these companies actually publish all of this information. But it's a fairly decent estimated guess. Our operations themselves, we're currently managed by about 6 operations engineers. That includes volunteers. We have a couple, 2 or 3 volunteers that work on our sites, which of course are not full-time, they're volunteers. So because of this, historically we've been operating in a very ad hoc firefighting kind of mode. Something's always breaking, and the traffic on our sites is continuously increasing, and historically the traffic was exponential. So we always had something breaking. We always had to do very clever hacks to make the site work while the traffic was increasing by so much with so little resources and essentially no money and no manpower. So our technical staff, all the 6 of us, we're across the entire world. We have 3 people currently in the United States, one of which is moving to Germany soon. We have someone in Amsterdam, and we have someone in another person in Germany. We have someone in Australia. This means that there's always someone awake, but there's never anyone on call because we just simply don't have enough people to have an on-call list. This is problematic, especially because the person that's awake isn't necessarily the person that knows how to solve the problem. So the way that things often work is when a problem occurs, we all wake up. We all get called in. So there's a couple ways we're hoping to solve this. First of all, we're hiring if anyone's looking for a job and has qualified skills. And the other way is by trying to get more volunteers to do operations engineering work. This, of course, is difficult because it's hard for us to give root out on our systems to volunteers, but historically we have. So we're not necessarily saying it can't happen, but later I'm going to talk about one way that I hope to be able to have more volunteer contributors without necessarily giving out root. We communicate generally on IRC for almost all of our communications. This works out fairly well. It's what the rest of our community uses, including editors, developers, both staff and community members. And even though we're very geographically dispersed, IRC works in such a way where we can ping someone and they can ping us back later. They can go look at the logs of the public channels. They can leave their client up and running so they can read the scroll back and such. It's a fairly efficient way of communication. All of our documentation is on a public wiki for at least at minimum our operations work. We have documentation for the software at another site. But unfortunately, we can't put all of our communications out in the public. We have some stuff that's sensitive and just can't be shared, like vendor quotes, for instance, or vulnerabilities and such. So we do have a few private lists and resource trackers. over time, we're trying to open up more of these things that we have so that we can document more stuff in the public and keep the private stuff limited to a very subset of the private things. So the architecture that we're using is basically a LAMP stack. For all intents and purposes, that's all it is. But since we've had such historic exponential growth on our sites, we have a number of clever hacks around this LAMP stack to make it work more efficiently, to make it very scalable. So this is our current architecture. And it's missing a few things, like it's missing mobile, it's missing our PDF servers, and a few other things. I haven't had time to update the slides in a while. But this is basically how our architecture works. So the diagram's slightly complicated, so I'm going to go through each one of the pieces individually. The first one that we're going to look at is the core of our application. And our application servers, it's MediaWiki, PHP, with running Linux. So this software, of course, is MediaWiki. This runs all of our production sites. So even though all of the sites are running this software, that doesn't necessarily mean they work the same way. We have a very large number of extensions. So each different project has a different subset of extensions installed. And by doing so, they can act in dramatically different ways. This is especially true for third-party sites that may act totally differently than the way our sites work. The software is developed primarily for our sites, but like I said, it's used by a large number of third-party sites. We have a very large open source community around this. The software is, of course, PHP. It's GPL'd. And the software is very scalable and very localizable. So it not only can be used by anyone, but it can be used by anyone in most countries. Our localization has we have support for roughly 300 languages or so. So since we run this on such a large site, we have to take optimizations, and we have to optimize quite a bit. The main ways that we optimize MediaWiki, first of all, is caching. If it can be cached, if it is more expensive to regenerate than it is to cache, we cache it. Secondly, we do a lot of profiling, and by looking at the hotspots in our code, we know what to optimize. And of course, if there's a feature that's too expensive, it doesn't get enabled. Now, when I say that, I say it loosely, because if it's too expensive to be run on English Wikipedia, for instance, it doesn't get enabled there. But there's a possibility that we may enable it on a smaller project for all languages, or we may install it on a specific language that has a smaller number of readers and editors. So for caching, MediaWiki has caches everywhere. We have caches for metadata, like image metadata. We have it for user information in their sessions. We have it for our parser cache. We have it for revision text. We have it for all of our localized messages. Most of this data is kept in memcache, which I'm sure a lot of people are fairly familiar with memcache, but it's simply just a key store pretty much. It has very basic operations like get, set, and modify. For opcode caching, we're using APC so that we don't have to reinterpret the PHP every single time we run it. And so actually one thing, we were using memcache for our parser cache, and we still currently are, but when we upgraded from MediaWiki 1.16 to 1.17 recently, we've noticed that the parser cache is having a problem in memory. The objects are too large, and so not very much of the parser cache is staying in memory, so the hit rate is starting to get fairly low on that cache. So one of our developers, Tim Starling, has been working on a solution to take the parser cache out of memcache and to stick it into eCache, which is an on-disk caching system. And by doing so, we'll be able to have more cache for the parser cache, but also have a larger amount of data that can be stored. What we noticed is that the on-disk cache is slower, of course, than in memory, but the amount of time that it takes to regenerate what the parser is doing is dramatically higher than what's on disk. So even though we're losing a little speed, like from latency, on going from disk, it's still a much larger gain because we can keep more in the cache, and we have more that's accessible. So from the profiling point of view, MediaWiki has a really great feature, which is that you can run your profiling data live at all times. And there's a number of different ways you can output the profiling data. You can output it to a file, you can output it to MySQL. And what we do is, instead of outputting it to those methods, we send our profiling data out via UDP to a UDP logging daemon. So the logging daemon is continuously keeping the profiling data from all of our different application servers and bringing it into one central spot. We have a tool that's publicly accessible where you can see at all times the profiling data that's live on our sites. This is really useful for us because when we deploy new code, we can immediately go and look and see how it's affecting the sites. We can clear out our current profiling data and see how it's affecting the site real time, so we can make fixes to the code. This is the way we profile, and we already see hotspots in our code and ways that we can optimize the code to make it faster for our sites. Of course, this is a core feature of MediaWiki, so anyone that is using the MediaWiki software can do this as well. So next up in the LAMP stack is how we store content. We're using MySQL for our relational databases, and as you notice, it's pretty traditional LAMP stack so far. But similar to how we add complexity into MediaWiki by using memcache and ecache and things like that, we also add a little complexity into our databases to make them more efficient and scalable as well. So our core databases, we optimize by doing things like separating read and write operations in a master and slave kind of architecture. We also separate expensive queries from more frequent and cheap queries by doing query groups. And we separate big popular wikis from less popular wikis on different database clusters, which is sharding. So this allows us to do load balance reads between our slaves and writes to our masters. And of course, some reads still come from the masters simply because they're not lagged. And for data that needs to be very up to date, this allows us to keep queries that are still up to date. Also, each wiki has its own database. That's not necessarily saying it has its own database server. It's just that it has its own database. That way we can move databases between shards when we need to. So next up is the least scalable part of our infrastructure. In fact, it's not scalable at all. This is our image serving, our media storage. And for this, we're using Solaris with ZFS. And this is the only proprietary part of our architecture as well. As I said, it's not scalable. We essentially have one server that has about 8 terabytes of data. The number of requests per second that we can actually do on this is very low. All of the application servers mount this server over NFS, and our uploads are written there. Our deletes delete from there for over NFS. And this is problematic when the image server is having issues. So when the image server goes down, all of the application servers now can't access the NFS server. This causes problems where we can't reboot any of the application servers. We can't do any operations that end up going in there. The web servers start having issues because they're trying to read and write into that. So this can lead to cascading failures across the entire site. Backups for this take about 2 weeks. This is not a good solution. So we have some future plans. We're going to be migrating to an open source distributed file system. Right now it's likely OpenStack Swift. We've been evaluating a number of different solutions over the past 3 or 4 months maybe. And this one's looking good so far. Some of the real good advantages to this is, unlike NFS, where all of your servers now lock up when your NFS server goes away, if the Swift server goes away, you have graceful degradation in your services. You might not be able to get to your images, but at the same time, the site should still render. The text should still be there, and you won't have cascading failures across the site because of this. And that's because it's using a REST API over HTTP. We're not doing a block file system. It's just calls to the media. Also, it's distributed. So unlike the system we have right now where it can't do very many requests per second, if we need more requests per second, we add more servers. We can load balance between the servers using the same solutions that we currently use, etc. So we're hoping to have this up very soon. We actually replaced one of our thumbnail servers recently that was running Solaris with Linux because we had a bug in the Solaris kernel. So we're very much hoping to move to this soon because we've been firefighting this for a while. Talking about thumbnails, this is actually one of my favorite hacks in MediaWiki. It's kind of cool. We noticed that stat operations on files take too long to run. So instead of doing a stat to see if a file exists, we use a 404 handler in a web server. When someone says, I want a thumbnail for this piece of media, it just goes and assumes that it exists. If it doesn't exist, it sends back a 404. Well, the thumbnail should always exist. If the media that it's looking for doesn't exist, we send a 404. If it does, it creates a thumbnail and sends it back. This eliminates a stat operation. Next up is how we scale our core application. The caching, like the way that our sites work and the use case for our sites is that, as I mentioned earlier, we have about 400 million users, but only about 200,000 of those are actual editors of the site. So this means that the majority of the traffic to our sites is read, which is a fairly easy case to optimize. So by using caching layers in front of all our application servers, we can scale very easily and cheaply. So what we're using for the majority of our caching is Squid. It's a reverse HTTP proxy, and we have this split into two groups. We have text and we have media. The text is most of our HTML content. It's when you go to Wikipedia and you see the main page, all of the text on the page, that's coming from Squid. Then we have the media group, which is large images and thumbnails. So all of the images that you're seeing on the front page of MediaWiki are coming, or most of those images are coming from the media group. So each one of our Squid servers has about 4 disks. They're seek IO limited, so the more spindles that you have in these servers, the better. They have about 8 gigs of memory apiece. Some of our new servers have more than that. They're also memory limited, so the more memory, the better. Since we've started using CARP, our hit rates for text are about 95%, and our hit rates for media are about 98%. So Squid really delivers almost all of the traffic for our sites. About 7% of the traffic is not. So for CARP, the way that we do our Squid infrastructure is that each Squid server has 2 Squid processes running. We have a CARP Squid, and we have a caching layer Squid. So in this diagram, I'm showing 2 data centers. And in this data center, depending on where the user is, they're either going to go to Amsterdam or they're going to go to Florida. So let's assume they're going to Florida right now. So when the client makes a request for a resource, they get directed into our Squids. They hit the CARP layer first. If the CARP layer has the resource in its cache, since it has a very small in-memory cache, it directly returns the resource. If not, it takes a hash of the resource URL, turns it into a number, and that number correlates to one of the backend Squid servers, the caching layer. So it then sends that resource to the same Squid server every single time it gets that request. So by doing so and not hitting the other Squid servers in the back, your cache is way more likely to hit. Similarly, if they come in to Amsterdam, which is our caching cluster, they'll hit the CARP layer in the front, which works similarly to the one back here. So let's say, for instance, the resource isn't in the front-end Squid. It'll hit the back-end Squid. If that one does not have the resource, instead of it talking to the front-end Squids in Tampa, this also acts as a CARP layer. And that CARP layer talks directly to our back-end servers in Tampa, which also majorly increases the hit rate. Equal. Each server has 2 processes. So when talking about caches, it's an important thing to think about is always cache invalidation. So when you're going to a Wikipedia page and you're browsing around and you see a typo on a page, you click Edit, and you go and fix the typo and you hit Save. What you expect to see is your is your edit immediately. You can't wait for it, and because of that, it's unacceptable for us to use expiration times in the pages. We have to do immediate cache invalidation. And we used to do this by hitting each one of our Squid servers in order and doing a purge on each one. But as your site grows and the more Squid servers you have, this becomes impossible. You'll never be able to purge all of your caches that way. So a coworker of mine, Mark Bergsma, wrote a patch to MediaWiki, which is one of the only patches he's done for MediaWiki, to do multicast UDP purges using HTTP. And what this does is when a user edits a page, MediaWiki sends a UDP packet to all of the Squid servers using multicast that immediately purges all the cache for that resource, of course. So Squid is really a front-end caching proxy that's been beaten into submission over time to be a reverse caching proxy. It's not really meant for it. Varnish, on the other hand, was written specifically to be a reverse caching proxy. And because of that, it's about 2 to 3 times more efficient than Squid at doing reverse caching. So we are using Varnish right now for part of our cluster. It's going to eventually replace all of the Squid that we have as well. What we're currently using for is a caching group called Bits. And Bits is our JavaScript, CSS, and other small static files that you would see in things like interfaces. We have 3 servers running this cluster. I think we added a 4th recently. It's very efficient. We're doing, I think, 25,000 requests a second per box. I think that's probably about right. Next up. So for some of every service that we have is clustered. For some of the services, we do clustering at the application level, like for MySQL, for instance, and for Memcache. But for other services, we are doing our load balancing via the network, layer 3 and layer 4. For this, we're using LVS. We're load balancing for things like Squids and Apaches. LVS is Linux Virtual Server. It's a standard feature of the Linux kernel. We're using LVS in direct routing mode, which means when a client makes a request for a resource, they hit our LVS server. The LVS server directs the traffic to one of the real servers in the back end. But instead of the real servers talking back through the controllers, they talk directly back to the clients. And what this lets us do is take in a very large number of incoming requests that are small while delivering a lot of traffic going straight back out to the clients. This allows us to not have things like 10 gigabit interfaces because the majority of the traffic is outgoing, not incoming. The unfortunate thing about using LVS is that it only works at layer 3 and 4. So you can't do things like load balancing based on requests or user information. The good thing, though, is since we've always had this limitation, we've just simply architected our application to work with doing load balancing at layer 3 and 4. So far, I've mostly talked about how we do things in one data center. And I mentioned earlier in the Squid caching part about having a second data center. We want our application to be fast everywhere. And so our primary data center is in the US. This makes our sites very fast there, but for other places in the world, it's not necessarily the case, so because of bandwidth limitations or latency and such. So the solution, of course, is to put data centers or data close to the users. Right now, we have 2 clusters on 2 different continents. We have one in Tampa, Florida, which is our primary. All edits that you do to Wikipedia go to this data center, for instance. We have a secondary cluster in Amsterdam that's caching only. We are currently adding a new data center in Ashburn, Virginia, which should be up soon, hopefully. And once we do that, we'll always have 2 primary data centers that can fail over to each other, and we won't have this issue of worrying about hurricanes in Florida, which is not a good thing to think about. So in our caching-only data center, we only have a subset of our infrastructure. We have DNS, we have LVS, and we have our caching layers, which includes Varnish, which is not up here. So the question is, how do you direct traffic to one data center? Or to the caching data center, that is. For this, we're doing geographic load balancing. So an observation is that most users are using a DNS resolver that's geographically close to them. And there are IP address to geographic location lookup lists that are fairly accurate. And also, when you're geographically close, that generally means your network topology close too. It's not always the case, but it's generally the case. So what you can do is you can map the geographic location to a specific data center. Mark Bergema, my coworker, wrote a backend for Power DNS called GeoBackend. This backend takes a list of countries and a list of IP addresses. It maps the IP addresses to a set of countries, which map to numbers. Those numbers map to CNAME entries in your DNS. So for instance, when a user from London makes a request to Wikipedia, our DNS server says, this is geographically close to our data center in Amsterdam. And so when they make a request, we send them back a CNAME that says, oh, well, you're going to text.esams.wikimedia.org, which is our cluster in Amsterdam. If someone in New York makes the same request, the DNS servers instead return a CNAME for text.pmtpa.wikimedia.org. Oh, sorry. Of course, this works fairly well with a coarsely distributed set of data centers. So we have one in Amsterdam, we have one in the United States. Since we're doing lookups by country, this works fairly well. But since we're going to have a data center in Ashburn, Virginia, and one in Tampa, Florida, this solution won't work very well for that those clusters, because it doesn't really know which data center to send things to. This is the solution we're currently working on, or this is a problem that we're currently working on, and hopefully we'll have a solution to share with everyone on this. It'll probably end up being some network trickery. So I've talked about our current architecture. And if you noticed, our current architecture is missing something. Specifically, it's missing a test and development network. Most of the changes that we make occur on a live site. We do some testing beforehand, like we'll bring up a couple servers, we'll do some infrastructure testing, we'll push the changes out. For developers, we expect them to test their changes in their local system. But when you're testing things like this, you're not getting to test them in an environment that's like production. So there's always going to be bugs that creep in from this. So I'm aiming to solve this. Historically, we haven't had this kind of environment for a couple of reasons. One is that we just didn't have enough money to do this. The other reason is that we don't really have enough manpower to do this. So the first one, thankfully, is easier now, because due to virtualization, it's fairly easy to bring up a few systems to make a whole bunch of virtual machines. The second one is still a problem. We still only have 6 people. We got 1 new person recently, but still it's not enough to replicate your entire environment. So the solution that I'm working on is what I'm calling the site architecture you can edit. And the idea is to build a virtualized environment that's going to be using OpenStack Nova, which is an open source EC2-like solution. And this is the current architecture I'm doing. There's 2 hardware pieces. There's compute nodes and there's a controller. The compute nodes can, of course, be a number of compute nodes, not just one. On the compute nodes, there's a service to make virtual machines or to manage virtual machines, and one to deal with storage for the virtual machines. On the controller is everything else. So although the controller is done like this right now, the end architecture may have a number of these services off on other systems. So let me go over a basic interaction of these services. So to the user, there's 4 services that are user-facing. The one that controls everything is MediaWiki. So I've written an extension for MediaWiki that I call OpenStack Manager, which is to manage the OpenStack infrastructure. And if you're familiar with EC2, this is like Amazon Web Services Console. If you're familiar with VMware, it's like Virtual Center. So the user can, an administrator on this wiki can create a user account for the user. When they do so, it creates the account in LDAP. After creating, when it creates the account in LDAP, it's also giving them access to the OpenStack infrastructure by making OpenStack credentials. It's giving them access to Gerrit, because Gerrit is using LDAP as a backend. and it's giving them access to the instances, the virtual machines. And that's because all of these are using LDAP as a backend for authentication and other information. So after the user gets credentials from an admin on the wiki, they can log in, which authenticates them against LDAP. Then they can add an SSH key for themselves, which also goes into LDAP. After doing so, they can do things like create an instance. Then they can create storage for that instance and attach it to the instance. They can allocate an IP address and associate that IP address with the instance. They can create a DNS entry that associates itself with the IP address. And when the instance starts up, also when the instance is created, that instance information gets added to LDAP, which is a backend DNS entry and its Puppet configuration, since Puppet is using LDAP for its Puppet nodes. So when the instance starts up, it's going to talk to Puppet and ask to join the Puppet cluster. Puppet will ask LDAP if this node is in LDAP. If it is, it's been created by MediaWiki, so it can add it to the Puppet cluster. Then it adds it to the Puppet cluster. The instance then asks to have the Puppet information from Puppet and then builds itself however the user asks it to build itself. So for instance, if on creation the user says, I want this to be an Apache server, and I want it to be configured this way by using Puppet variables, that's how the system will build itself. When the system builds itself, at the very end, one of the things that MediaWiki automatically puts in for the Puppet configuration is the username of who created it, the person's email address, and their language. So when the instance gets to the very end of its Puppet configuration, it sends an email to the user based on a MediaWiki template that says your instance has been created, but it does so in the user's localized language. After the instance is created, the user can log in via SSH using their SSH key by SSHing to the public DNS name. So this is how users will be able to create their own instances, but you also want them to be able to modify the Puppet configuration too. So we're going to take the Puppet configuration for our live sites, and we're going to add it to a Git repository. We're going to strip out all the private information, of course. But this will allow users to be able to pull their the Puppet configuration for the entire site, and from the Git repository, make changes, and then submit them as merges for approval. We'll be able to go in, the operations engineers, and say, yes, this is approved, no, this is not, automatically merge, and if it's approved, automatically merge this in. So what I'm hoping to do is to have staff developers, volunteer ops people have the ability to modify our Puppet configuration and have them pushed all the way to the production cluster. So the basic use case for this is going to be, so OpenStack has a concept of projects. And each one of these projects has restrictions or rights that you can give users. So I can say that in this project, user A has the ability to create instances. They have the ability to make IP addresses, or to associate IP addresses and such. So we're going to have a default cluster, which is going to be a clone of the production cluster. In this, it's mostly going to be used for test and development and maybe operations tasks. So most users will not have root here. Operations engineers will have root, and it's going to be essentially kept stable. For new projects that we're working on, for instance, we have something we're working on right now, Open Web Analytics, to integration into the Wikimedia Foundation sites. This is something that requires new infrastructure. So, and the people that are working on this is mostly software developers and not the operations team. So they need architecture to be able to do this. So what we're hoping to do is make them a project, give them rights to manage that project. They can create all of their own virtual machines. They get the environment working the way that they want it working. And then once they think it's ready, either they can pull out the Git repository for Puppet. They can add in their manifests, their files, and their templates. Make a merge request. We'll merge it in. We'll launch the instances on the test and dev portion of the cluster. Make sure that it's working in an automated fashion so that we don't have to make any manual changes to get the systems up. And then once we're sure that's working in our infrastructure, we can order hardware, get the hardware in, ready, attached, and then push out the puppet configurations to our production cluster and bring those systems up. So the idea is we'll be able to have developers come in, build their infrastructure from scratch, move it all the way from the test and dev environment that they manage themselves into the production cluster with the operations team only having to do merges. So, of course, the way that we're doing this, we're kind of running our operations infrastructure as a software development project. Because in reality, when you're doing puppet configuration and such, you're doing software development. You're writing puppet manifests. This is really just software. So this is where you guys come in. We love to have help with everything that we're doing, and we're overworked. So having community participation is really nice. And this is also a great way to have someone come in and be mentored by someone that has experience in large sites, and to be able to involved in a project that's very large and nice. So I'd like to talk quickly about how you can engage our community and how you can become a member. So the first thing about engaging our community is that you should discuss what you want to do. When you come into our community and you discuss things ahead of time, it kind of lets us know what you want to work on. We can assign the right mentor to you. We can, even if you don't want a mentor, we can talk to you about how your design is looking and maybe give you suggestions on how to change it and things like that. So after you've discussed your project with us or your idea, then you should start committing code. And you can do that in a couple ways. You can either submit patches to us, or you can apply for commit access. We give out commit access fairly liberally. Pretty much we just need to know that you have some PHP experience and that you're not going to break things, which is not that big of a deal. So after you start committing, it's really important to actively participate. And this, what I mean by this is, so we have processes like code review. If you submit code, you should be actively participating in the code review portion of that. If you have fixes on your code, you should be fixing them. If someone has made comments about your code, about how it's architected, you should answer them. Similarly, in the mailing lists, if a topic comes up about what you're doing, you should talk to them about that. And other things like that. Also, you should be documenting your code. And I know this is an obvious thing, but it's more than just documenting the code itself. You should also put documentation on our wiki about it. If it's an extension, for instance, you should make an extension page on MediaWiki.org that says how your extension works, how to install it, and things like that. Also, if you're making core code changes, you should be documenting those on the respective pages for the documentation. Lastly, you should communicate the changes you're doing. If you're making a breaking change to something, it's really important to communicate the changes, because there's a possibility that someone's working on something. They've been working on it for 2 or 3 weeks. You make a breaking change to something, and they didn't know about it, and you've wasted maybe a week or 2 of their work. So it works really well when you communicate with us. And I mean, really, communication is key for everything in an open source project. So like most open source projects, we have a very similar philosophy. And the first one is engage early, which the first thing I mentioned before was the first thing you should do is discuss, right? This is the same thing. When you engage early with our community, it makes it so that we can help you earlier on. We can work you into our processes. We can tell you how you're doing things wrong or how you're doing things right, or where our documentation is for things and such. Also, you should be releasing early and releasing often. The OpenStack Manager extension that I wrote, I released it before it even had the ability to do security for basic things like creating instances. So really, it's not terribly useful as an extension, but it shows people what I'm doing. It shows people where I'm going, how I'm architecting it, how things are going to be working. And it's similar with release often. The more often I release my changes, the easier it is on code reviewers. They can see what I'm doing as I'm doing it, and they can steer me in the right direction. Or it makes it easier for me to fix bugs, especially bugs that are going to bite me later on. I had one recently where I was taking the revision of an article incorrectly, which would have given me a random article in the wiki, and then edit it, which would destroy the text. I would have no idea how to fix this later on. But someone pointed it out very early on in the process, so by releasing often, I save myself work later on. Lastly, you should scratch your own itch. So just because you're part of a community doesn't necessarily mean that you have to work on what we want to work on. You can work on whatever you want. And we actually encourage this. So we have a number of high priority things that we need to get done, but just because you're doing it doesn't mean you have to. So you can work on any extension you want, even if it's not going to be useful to us. So the way that I actually got involved with Wikimedia to begin with was I was working for another organization, and we wanted to use a documentation system of some variety. And I saw Wikipedia at the time, which was kind of a new website, and I thought, this seems kind of perfect. Like, if all these people can get together and write an encyclopedia together, I think our office can use this to document things. So when I installed the software, I noticed, well, the authentication system has problems. We're going to have another set of users and groups and everything. So I decided to add LDAP authentication support to MediaWiki. And although this has absolutely no use for Wikimedia Foundation, after I released this, it had a lot of adoption, specifically by third-party organizations, by large enterprises and such, that otherwise probably wouldn't have been able to use MediaWiki, because most large enterprises expect to have their authentication integrated. So by doing this, it largened our community. And by largening the community, it allows us to have more developers that are giving back code. And with them giving back code, maybe they're going to put something out that is very beneficial to us as the Wikimedia Foundation. So I definitely encourage you, work on whatever you want to work on. It helps us. So there's some things that you need to know when you're specifically coding for Wikimedia Foundation sites if you decide to do so. The first one is security. Security is really important. It's really important. People rely on us as developers to put out secure code. If there's an extension that you've released in Subversion, for instance, that's insecure, there's a large number of third-party sites that may download and install your extension. Now, all of those sites and all of their users have a vulnerability. Also, if your extension is insecure and it gets installed on Wikipedia, that's 400 million users that are now vulnerable. But there's a compounding effect. Not only does it affect all of those users, but third-party users are much more likely to install an extension if it's being used on Wikimedia Foundation sites, because they know we're going to support it, they know it's going to be scalable, they know it's going to be localized, and things like that. So not only are you affecting 400 million users, but you're also affecting all of the users of all of those other third-party sites. These are the most common vulnerabilities we see. Any of these vulnerabilities, and really any vulnerability, will cause your code to get a revert, which is, good practice. So I'm not going to go into each one of these into detail, but if you're coding for Wikimedia Foundation sites, these are definitely ones you should be looking out for. So some general notes on how to avoid these is, first of all, don't trust anyone, not even your users, especially not your users. And you should sanitize all of your input. And things like this are a lot easier if you use the tools of the framework that you're writing in. So for instance, for a lot of the vulnerabilities that are up here, if you use some of the built-in MediaWiki classes that are recommended, you won't get these vulnerabilities at all, because they automatically protect against them. And this is part of writing code that's demonstrably secure. The idea is when a code reviewer is looking at your code, it should be very easy to say, yes, this code is secure. I know it's secure because they're using this class and they're using it in this way. It's a normal pattern for us. So when their code reviewer looks at it, he doesn't even have to think about whether it's secure or not. And the best tip that I can give for this is try to hack your own code. It's fun, and it gets you into the right mindset. So when you are attacking your own code, you're thinking, well, an attacker can use this to come in this way. And so the next time you're writing your application, you'll already be in the mindset of, well, if I write it that way, someone's going to be able to get in this way. Next, Wikimedia Foundation sites are very large. It's the 5th largest website in the world, and because of this, we get a lot of requests. So code has to be performant, and it has to be scalable. And by performant, I mean it needs to be able to run quickly, and it has to be able to run proficiently. And by scalable, it has to be able to run quickly when you have a very large number of requests, and you're on a very large data set, and you're scaled across 100 or so systems. This is an example of a problem we had where the code we were using was not performant or scalable. And this is actually Varnish, but we had a patch to Varnish that does GeoIP lookups. We, during our fundraiser, we serve fundraising banners. And we wanted to send the fundraising banners in such a way to where if we were going to do one that was US-centric, we send it only to the United States. Or if we want to do an ad campaign that is, or a fundraising campaign that is specific to Japan, then it will send those banner images only to people in Japan. So the patch itself had a memory leak, which it's a really, really small memory leak. But when you're getting a large number of requests, the memory leak has serious problems. So if you notice, this flat line is the normal operation of the server. This is where we installed the patch. And this is 1 week time. In 1 week, it ate up 30 gigs of memory. We didn't notice this in time. And so once it hit swap, the number of the load of the systems that it was on went to 3.5K, which is really high. This is a site outage. Specifically, when our bits cluster went down, it caused cascading failures in the rest of our services. So the entire site went down because of this. Here's where we restarted the servers and reclaimed all the memory. And over time, it went back up. We noticed it, and we reclaimed the memory. And here's one time we didn't notice again. The site went down for 30 seconds or so, but still, it's a site outage because of something like this. One more week went by. Then we had a hackathon in Washington, D.C., and we decided one of the things we're going to fix for this is going to be the memory leak. And it went back to normal operation. If you notice here, the amount of RAM used is still twice what was originally used. But that's actually normal. When we added this patch, we doubled our traffic to those clusters, or to that cluster. We fixed this later on by caching the GeoIP lookup cache, or by adding a cache for GeoIP lookups. So for scalability and performance, basically you do the same thing that you do for the hardware infrastructure. First of all, you cache things that are expensive. Second, you profile your code so that you can see what hotspots are in it, and then you can optimize those pieces of code. So if I can say one thing, if you're going to code for Wikimedia Foundation sites, it's this last one. Ask for advice. Optimizing your code and doing caching is difficult. It's complex. And we have a large number of people in our community that are experts at this. We love to give advice for this. If you're going to be running code on our site, we're going to have to do this at some point in time anyway. So the earlier on you ask for advice, the easier it is for us. And not only that, you get to learn, you get to learn how to do these kind of things. So also, when you're running on Wikimedia Foundation sites, you always have to assume that you're running on a cluster, because everything is clustered. This can be problematic. Since your code is running in a number of places at one time, you're running concurrently, you can run into bugs, you can have deadlocks, you can have issues with conflicts of your code running in two different places at the same time, which cause really, really strange bugs. So, some closing notes. As you've noticed, we rely heavily on open source. We like using open source. We find the support in open source projects to be better than proprietary projects. We find it to be more reliable. We find the response times from support to be quicker. We get to talk directly to things like lead developers instead of talking to tier 1 support. We also get to fix the problems ourselves when we notice problems that we can fix and send the patches upstream, which then get maintained by the developers. This is something that we can't do in proprietary software. Using open source software helps us a lot. It makes it so that we can have less people. And so we're always looking for efficiencies in our environment. This is both the code, by doing caching and optimization of the code, but also efficiencies for people as well. So we're looking for more efficient management tools, for instance. So we started using Puppet about 1.5 years ago. That helped us. Now I'm writing this OpenStack extension and making this architecture so that we have the ability to do more things with less ops infrastructure. So we only have 3 ops people, but we have 25 or so developers that are on staff. We have a very large developer community. And so by leveraging them, hopefully we can take less time of operations engineers and move that to developers who really kind of want to do that anyway. So now that I'm saying that, we're looking for more contributors. We'd love to have more volunteers. We're also hiring right now for a number of positions. We're hiring 3 or 4 operations positions, and we're hiring probably, I guess, 10 or so, maybe more dev positions. So if anyone's looking for some work or wants to work for a really awesome organization, by all means. Questions?
I know this is fairly naive since I haven't cut into your code base, but just from the outside perspective, it seems to me that you could just save every page as an HTML file, not even use anything on the server side, just CDN it, if you're willing to accept eventual consistency. Is there part of your use case that prevents that kind of a strategy?
So we've looked at Akamai before and other CDNs. A lot of CDNs have some restrictions that we can't accept. So, and when I say that, it's technical. From the perspective, Akamai's invalidation time was something like 5 minutes last time we talked to them, which for articles is just not going to work. When you edit an article, it needs to be updated immediately. It could probably work for things like images. We're looking at things like this. But part of it is also, it's generally usually cheaper for us to do it ourselves. Yes?
Can we get more information about the Squid and invalidation strategy? Have you guys implemented that?
Wikitech.wikimedia.org, and also MediaWiki.org. And you could look at the implementation in the software too. It's open source, so, or you can ask me. Well, I'm on IRC on a bunch of channels. Oh, sorry. He was asking if he could get more information about the caching strategy with multicast GDP.
Look at any alternatives to OpenStack.
Yes. He was asking if we've looked at alternatives to OpenStack Swift. And we looked at a number. We actually have, we hired a contractor to go through all of the options for us, and he documented everything in the public on wikitech.wikimedia.org. So if you go to his pages about his different options, he has all of the pluses and minuses for the different ones, and why they fit our architecture or why they don't, and also about how easy it would be to integrate in a MediaWiki or not. He asked if why we're not using cloud servers and instead owning our own hardware. So it's good for us to be in control of what we do. If we're on cloud servers, we are essentially tied to that organization, right? So part of our mission is to make sure that we share knowledge with everyone. Having us tied to an entity is problematic for us, because although it's not likely for that organization to exude control over our content, there's always a possibility. But even then, I mean, we don't have that many servers, and it's not that terribly expensive for us to manage the infrastructure. So whether it would be cost efficient for us to run in the cloud or not, I don't know. But also, our downtime is totally due to us, right? So we don't have to worry that our downtime is because of the hardware resources of a third party. We've also optimized our infrastructure specifically for certain types of things. So if we're running in the cloud, we may be running on a server that has 10 other things. And if we're running our database servers on there, that server is not necessarily optimized for databases. Our Apaches that hardware wouldn't necessarily be optimized for Apache. And we're sharing the hardware with others, so the performance of those other virtual machines may also cause us problems as well. We have a lot more control over things the way that we're doing it. Yes?
Like, do you have anything to, like, I mean, how is it supported? Like, is it a new focus system? Does it support, like, workflows? Like, how is it compared to other code review systems?
So he was asking what our experience with Garrett is and how it compares to other code review tools. So to be totally honest, I just started using Garrett. I've evaluated it for use for this specific project. And really, what I wanted was a distributed source control system specifically. And then I choose Git because our community is also looking to get as a possible alternative subversion. So it made sense to use a tool that was similar to ours. I mean, something that we're already looking at. So I don't really know. I know that the code review tool system that we're using for MediaWiki is not something that we're totally happy with, and some community members are also looking at Garrett as an alternative as well. So I can't really answer your question terribly well. So I'm not necessarily the community person, so it's hard for me to answer. I know that a lot of our volunteer contributors come from editors from Wikipedia. So they are already very interested in our project. They're already very mission dedicated. So how we attract them, I mean, I would have to imagine it's just because they really want to work on the project, that they're really into it. But otherwise, one of our community people would probably be better at answering that. Yes.
I just had a related question to that.
Okay.
How is usage going with community contribution? Is that something up and down? Is it growing over time, or is it, how's it going?
He asked how our community growth is over time. I would say it's fairly stable right now. How it's been from the past to now, I don't really know. That's we probably have statistics on this somewhere, but right now we have the number of committers we have is at about 300, maybe 320, but not all of them are actually active. I think we probably have 50 that are really active right now, but I don't know how that compares to the past. Oh, you had a question?
I was curious, I'm new Wiki myself, but there's been a lot of noise in the semantic web. Have you been at all involved with our community? Do you find it worthwhile?
He said semantic. We have something in IRC where a bot, if you type that in, says really funny things. So he's asking about the semantic web and how we're using technologies like this, or if we are. And so in general, we're not using anything semantic. There is something called Semantic MediaWiki. It's an extension to MediaWiki that allows you to add annotations. And there's a number of other semantic extensions that kind of revolve around that ecosystem, like semantic forms and semantic result formats and external data and a few other extensions like that. And so although we're not currently using those extensions, and we may never use these extensions, we probably will be doing stuff with semantic data at some point in time. It's really useful. And specifically in the project that I'm working on right now, with OpenStack Manager, it is using semantic MediaWiki. And it's using it in such a way when, like, if you create an instance, it pulls all the information from LDAP and from OpenStack. It takes those different properties with values and adds them into a MediaWiki template. That MediaWiki template, since it's in the system as a wiki page, automatically has all the properties associated with that, and then you can use those properties and make queries. So I can do something like show me all the instances that have over 20 gigs of storage, and I want to take all of those and I want to sum it up, and I want you to show me how much storage they're using total. So, and this is just by having wiki pages in there that are semantically marked up. It's really awesome technology, especially for very specific use cases. It's just that a lot of these technologies are very resource intensive. So for the semantic properties, you have to have triple stores, and you have to have all of these other things. They add a lot of complexity, and it's difficult to easily integrate into a system. And especially from the user interface point of view, semantic technologies are fairly difficult to use that way as well, because you have to have some way of adding the properties in. And with Wikipedia, one of the things that we already have right now is that it's kind of hard to edit. So because there's no what you see is what you get editor, and by adding in semantic annotations into that already complex markup, it makes it way more difficult. So there's a number of reasons that we're not currently using it, but we hope to use it soon.
Is the WYSIWYG editor a project you look to?
Yes. So he's asking if WYSIWYG is something we're looking at doing. Yes, we would love to have a WYSIWYG. Yes. I'm sorry? He was asking if we use test unit. We're using PHP unit and Selenium. So those are projects that are currently being worked on. They're still in their kind of their infancy stage. We don't have smoke tests, for instance. We don't have very much code coverage, but if it's something you're interested in doing, we'd love to have help with it. Yes.
Basic question regarding Wikipedia and the data. Like, how can developers making their apps use data? Like, do you have public APIs or RSS feeds, or how can we grab data? Like, customize what we need.
Okay. He's asking if we have the ability for third-party applications to pull data from us using APIs or something like that. We do have an API. We have both a read and a write API. They export in a number of formats: XML, JSON, YAML, etc. I'm sorry? REST-based? Yeah, they're REST-based APIs, yes.
Since you're talking about stuff that kind of need, is it possible to speak generally about areas that you need help in?
Yeah, we're hiring a number of areas right now. We need a DBA. We need a performance engineer. We're hiring for mobile because our current mobile site is written in Ruby, and it's very disconnected from our MediaWiki code base. So we're going to be porting the Ruby application into PHP and hopefully integrating it much better with MediaWiki, so that third-party sites can also have a mobile presence and such. So that's an area. There's always the parser. The parser is kind of the bane of most of our existences because it's a bunch of regular expressions. It has no formalized language, which also makes other things more difficult, like what you see is what you get editors. If you have no way to parse the MediaWiki text, yes, parsing the wiki text. So that's always a project that you could work on. That has a number of corpses lined in your path. Let's see. I'm sure there's more that I'm not thinking of right now. There's quite a bit of stuff to work on if you're interested.
Is there a hit list somewhere that's
Probably not. We probably do not have a hit list of things that we're working on. We may have one somewhere. I'll ask about it. I've asked about it in the past and don't really remember the response. But I'm sure we can put a list out there if we don't already have one.
just post it back to the meetup.
Yeah.
Where do you get information about the APIs?
He's asking where we get information about the APIs. If you actually, the API is self-documenting. So if you go to either install MediaWiki and look at the API class, or just hit Wikipedia on the API, it'll print out HTML documentation. Or MediaWiki.org should also have documentation about how to use the API. Anyone else? That's a good question. I'm not terribly familiar with the profiling, except it's mostly custom written, and it sends UDP packets.
You know if it handles 100% of tests, or sorry, is it all tests or just a subsample?
That's a good question. I don't remember if we track all of the. I'm not sure if we do all of it. Cool.
The way the profiler system is crafted, you just go from code, the profiler in and the profile out block, and you add a comment every time. It goes into the output. You can actually, I don't know if this is enabled on Wikipedia, but if you do force profiling to one, it will put the profile information in comments at the end of the code. There's also a force trace equals one, which will give you a trace of the profiler will also look samples.
I think that's right. Yeah.
That's a good question. So what about licensing? Like like what kind of license do you need if you want to use data from Wikipedia for anything?
So he's asking about are you asking about the content license?
Yeah, content.
Okay, so to reuse the content, all of our content is Creative Commons by attribution, I believe. And so to reuse that content, you just have to, you just have to go by that license. I think we have other things uploaded as images and such that are not Creative Commons, but it depends on which resources you're using. So the content all the content has licenses associated with it, so just have to follow the license of the content itself. Yes. He's asking if if the application MediaWiki is doing all of the rewrite queries itself. Yeah, we have the databases can you can tell it which servers are read and which ones are write, which ones are the master and which ones are slave. You can make query groups and such. I'm not really familiar with that part of the code, but that's last I looked, that's how it works.
General question. What about Wikipedia, like Wikimedia, the organization? Do you guys get money from the government too, or is it just private, like donations and stuff? Like, how do you make money, or you plan on making any commercial, plan on making money from stuff like that?
So I'm not probably the best person to answer this, but knowing the normal stance on this, we don't ever plan on commercialization. We're donation-based. Mostly, the majority of our money comes from small donors, whereas some of the other money comes from grants, both public and private, some anonymous and some named.
From government?
I'm not sure if, I don't know if we've gotten grants from the government. I know we get grants from Google and we get grants from Microsoft and Yahoo and such. But whether it's from the government or not, I don't know. I don't really know our fundraising stuff as well.
And how do you deal with challenges like different Wikipedias in different languages and stuff, right? Like from a programmer, standards and stuff. But how do you deal with Wikipedia, like the thing which you edit, how does that handle
So he was asking how editing in different languages and just I guess dealing with the interface as well is done. So we have projects for each different language, and the interface for those projects is in that language. For the localization of the software itself, that's done by a community called translatewiki.net, which is not a Wikimedia Foundation project, but they translate our software. They translate Akawix, I think. They do Wikia extensions as well. Yeah, they do. And and a number of other applications, but they're like Wikipedia. They translate via Wiki, and it's open to most people to edit.
But every a topic in Wikipedia in English, not necessarily if you read in German, or some other language, it won't have the exact same information. Like it may have less information or more. Like that's a feature. Like I would like to see, in different language have the same information. Because some languages there's a lot of information, and Chinese, whatever, only information about some topics, and the other topics they're not there.
Yeah, so it's difficult because translation software is still not very good, automated translation software. So pretty much like all of these different topics on these different pages are going to be translated by a human, and these different cultures they have different views on these different topics. So they're always going to be slightly different. The idea is for editors to be neutral, but it's not always the case, and sometimes cultural bias enters in and such. But yeah, I understand what you're saying. It would be nice to be able to see more interaction, but it's a difficult problem.
And another thing that's just amazing, how soon you guys get your content updated. Somebody famous dies today, right now, it'll be up next hour or something. Who, this community puts that up, or you have people working on breaking news?
No. All of our content is done by volunteers. All of it.
And the live changes, is pushed right on the live server, like you said earlier, right?
Yeah, so like on the main page, even the main page, for instance, is all volunteer based. All of the interface for MediaWiki is volunteer based. The JavaScript, the CSS. Sometimes we have staff that'll go in and fix certain things. Like if we're making a large change to the software, and we know that it's going to break the JavaScript and CSS that community members have made, we'll go in and we'll make tweaks, but we still participate with the community on that. We let them know what we're changing, why we're changing it and such, and guide them to make the changes themselves so that maybe we don't have to do all the changes. So most things are community-based. And really the foundation is kind of just a big wrapper around a very large community of volunteers.
Has the all-volunteer nature created any obvious gaps in information covered? Because something is just so obscure or boring that nobody wants to write about it?
Well, so I'm really not the best person to talk about content or that part of things. but I can answer that from a perspective of the software. So people want to work on what they want to work on, right? So I would have to imagine it's similar in the content, but for the software itself, when you have mostly people that are working on what they're interested in, there's always going to be things left out. Like some parts of the software just aren't interesting to work on at all, or they're really, really difficult. And so unless you're going to pay someone to do it, it's just not going to happen. But for the content, like I find the coverage of Wikipedia to be amazing. I don't know, personally. Yes.
So how do you handle if two people are editing the same page all at the same time?
So he's asking how conflict resolution occurs on pages when they're edited. So I'm also not the best person to talk about this. So I do mostly ops, and I do volunteer development and a little bit of development on the side. But the changes are merged. The pages can be edited simultaneously, and as long as the same line isn't edited by the same two people, it merges seamlessly. And I'm not sure. Do you know how is it line based or is it word based inside of lines now? Right. It merges the two. Yes. Yeah. The last person to edit it gets a conflict notice. No, there's no locking. It merges changes automatically if it can. And if it can't merge the changes automatically, the last person to edit it gets a conflict page. But even then, like if they're both editing the same page at the same time, as long as they're not editing the exact same thing in the same page, it'll just merge both pages and no one gets an edit conflict.
It's similar to like the subversion
Yes.
AB tag, and then someone just goes in and patches it themselves.
Yes.
One more kind of point, maybe, like he was talking about semantic web and how, web is like, there are new, like, languages for the way to write, HTML, like content on the web, it's HTML5, and there are new things out there. So, like, it would be really cool if Wikipedia can create some kind of like, how Facebook created the social graph API, and there's talk about like interest graph, because Wikipedia has so much data, it's useful, and some kind of like a graph API that can, developers can use for their own applications, something like that, or companies can use.
Well, I mean, all of our data is reusable, and we have an API. So anything that is going to be created, I mean, if that's something you're interested in, I mean, that's definitely something to work on, right? Yeah, it does. RDF is something like it's an XML format that essentially defines a triple or a set of triples in a page. There's also inline HTML ones like micro formats, micro data, and RDFA. So
apart from optimization and code cleanup, are there any kind of high frontier next generation projects you're trying to tackle?
So he's asking if there's any large, high-profile, next-generation things that we're trying to tackle. Yes. So one of the things that the large one is going to be a parser rewrite that we're hoping to have completed at some point in time. That's going to be a reusable parser that has hopefully a formalized language and such. But we'll see how it turns out. The other one is what you see is what you get, because that in MediaWiki has been a very large problem for a very long time. Exactly. Yes. And I know for a while we were trying to coordinate with you guys on the WYSIWYG. I'm not. Yeah. Oh, that's good. Yeah. Cool. Yes. Well, so we're not using it just yet, but he's asking if we're using something else. I'm sorry.
Yeah, my question is, what was the time limit?
I'm really definitely not the person for this question. Tim Starling, in his he wrote an email out to the list that kind of went through the different options he looked at and why he chose the thing he was looking at. So that's probably the best way to explain it. Or I'm really just punting to say go read the article or his mailing post, because I'm not really probably the right person to answer the question. The developer list is, so we have one for support, which is MediaWiki L, and he's asking about the mailing lists. The other developer mailing list is WikiTech L, and you can find the mailing lists by going to MediaWiki.org and doing a search for mailing lists, because it's going to be hard for me to give the addresses. Or you can search on Google for WikiTech or MediaWiki L.
Or I'll email you.
You can do that too. You can email me. Or hit me on IRC.
For those of us who are also writing our own frameworks, what kind of corners have you painted yourself into that you could advise people not to do in their own code?
Don't write a parser with regexes. No, but I mean, to be honest, like, so even though I do some development, I'm not really the person to probably ask for really hardcore development questions. For those, I would punt to like some of our lead developers.
So I noticed on your architecture diagram,
Oh, no, it was, so he's asking what we're using for search. No, we're using Lucene. Yeah.
And you talked a little bit about how you synchronize data between MySQL database and what are your update leaks? Partitioning the same way?
A volunteer does all of our search. So unfortunately, I don't really know much about it. On IRC, he's Rainman SR, I believe, or something along those lines. He would be able to answer your questions. We're still getting a hold of that part of the architecture.
You always use Lucene?
No, I mean, from search technologies, it's always been Lucene. We were using MySQL at some point in time for searching, which, as you know, is probably not very good for search. Lucene has been much better.